Sorry about that. Hey everybody, this is Mr. Bells here. I was recording another video and then it just got interrupted, and there's no pause button on the way I'm setting these up. So I'm starting right now with the rational exponents slash radical equations topic right now. This is for section 5-4 out of the Big Ideas Math textbook, and here we go. Here's what it's like to solve some of these radical equations. So one of the first things is this, because I have lots of examples down here, as you see. We want to talk about how they work out. So we're going to start with something like this. Anytime that you're going to try and solve a radical equation, the first rule is to make sure the radical is all by itself. So you'll see on number 2, there's a 4 on the outside and there's a plus 9 after the last line of the radical. Those things are going to have to be moved or dealt with before we can solve the equation. So I'm just going to kind of go through some of these things as we go, and here we go. So right here, this radical is completed on that side, so I have to ask you, how do I get rid of the square root? Well, of course I square the number. So I'd square on both sides. This square root kills that square, and I'm left with 3x plus 2 equals 8 squared being 64. And now the algebra, basic algebra, comes into play. I subtract 2, I subtract 2. 3x is equal to 62. Divide by 3, and x equals 20.6. Repeating. Now, just so you know, we can go ahead and I'm going to show it to you on this calculator too, because I haven't pulled this out in a while. I'm going to show it to you on this calculator. We're going to go ahead here. Y equals. I'm going to put in the square root of 3x plus 2. Which means, technically, I could do it like this, right? Parentheses 3x plus 2, parentheses, raised to the 1/2 power. Remember, older calculators put that in parentheses so that we know it's there. And I want to know where that equals 8. 3x plus 2 to the 1/2 equals 8. Assume 6. So you can see this is my function, my square root function, and that's what it looks like when we shift it and tweak it. And here's this red line, so they have to hit, but you can see they hit off the screen someplace. So on my window, I'm going to have my X max go to like 50, and then you can see that again, and oh, look, there they hit right there. Second trace, number 5, intersection, enter, 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 and you can see right there, maybe zoom that in a little bit, 20 2/3, same thing that we got when we did the algebra. Okay, so there is an example of just using the calculator, not that I have to use it each time. I'm going to move on to the next one right now. So here, I have to get rid of the 4 and I have to get rid of the 9, but I have to make sure I do it in the right order. So I'm going to remember, PEMDAS backwards, right? So PEMDAS, P-E-M-D-A-S. I've said this many times, but when you're solving an equation, you got to work backwards. So get rid of addition, subtraction stuff first. That's plus 9. So minus 9, minus 9. And then I get 4 times the cube root of 2x minus 7 equals 73 minus 9 is 80. Oops, sorry. 64. 64. Awesome. Divide by 4. Both sides, and I get the cube root. Make sure you keep the little 3 there. 2x minus 7 equals 64 divided by 4, was that 16? Looks like 16. And then how do I get rid of a cube root? I have to cube it. Move that up to there. So third power. Whoa, that's big. 2x minus 7 equals 16 cubed. I don't know that off the top of my head, so 16 raised to the third power. I get 4096. 4096. And then add 7, and 2x equals, so 4096 plus 7, enter 4103, and divide by 2, then I get 2051.5. 2051 and a half. Double check that. Yeah, I got it. So that's what x equals. Okay, at least it's supposed to equal that. So I'm going to show you another thing on the calculator. that I want you to get better and better at. So let's try it. So that I'm going to store an X. So I'm going to hit the STO button, right? That's that button right there, STO, store that value in X and hit enter. So now that's stored in X. Remember, if we don't want that stored in X, we don't have to change it. We just put something on top of it that's different. Okay, so now I'm going to type in the left-hand side of this equation right here. So I got 4, and I'm going to do cube root. So if I wanted to, I can get it in here, math, button number 4. See that? It's my cube root, 2x minus 7. And now I don't want the plus 9 underneath the radical, so I move that over there, plus 9. On the older calculators, remember, you got to put it in parentheses so we don't lose it. And I'm just going to hit enter. And you can see that it says it equals 73. That's what I wanted, 73 right there. So we got a winner. So again, please put stuff into your calculator to check afterwards to make sure that you did it right. Okay, here we go. I got 1/4 to the 5th root of 3x minus 2 plus 8 equals 16. Step number 1, minus 8, minus 8. So I get 1/4 times the 5th root of 3x minus 2 equals 8, because 16 minus 8 is 8. Times by 4 both sides. So now I get the 5th root of 3x minus 2 equals 32. Raise it to the 5th power, raise it to the 5th power. Like, oh my gosh, that's a big one. 3x minus 2 equals, because that's 32 times 32 times 32 times 32 times 32, right? 32 raised to the 5th. I got 33,554,432. Add 2 and divide by 3. Add 2, enter, divide by 3, enter. And I get x equals 1,1184811.33, comma, and comma. Looks like 11,184,811 and 1/3 0.333 as we go. Cool. That repeats. Okay. So far so good. Again, I have to isolate the radical before I solve any of that stuff. Now I'm going to try this one. It's like, ooh, there's a radical on both, 2 radicals. And I can't subtract these 2 things because the stuff underneath is not the same. And my apologies on this one. If they both had, this had a cube root and that had a square root, I'm screwed, can't do that kind of stuff. So I just forgot the little 3 when I wrote it down. So hopefully you've paused the video and you've written this down. So now I've got, I'm going to move this whole thing to the other side. So now I've got the cubed root of 2x plus 3 equals the cube root, because from minus to positive, cubed root of 4x plus 2. So now I got this equals this. Hey, I should cube both sides. So I cube both sides, and that should kill the radical. So now I get 2x plus 3 equals 4x plus 2. Subtract the 2x and I get 2x, and I subtract the 2 and I get 1. 1 equals 2x, divide by 2, and I get x equals 1/2. So supposedly these 2 things, the only place that they intersect is when x is 1/2. So again, I can do this with you guys. Go ahead. Grab your little thing right here, and we're going to try this. So I'm going to do second, nope, not second, I'm going to do math. I'm going to do number 4. Cube root of 2x plus 3. Move that over. And minus, I'm going to do math. Cube root of 4x plus 2. Just like that, right? And I'm going to hit enter. And I just realized I forgot to store x. So I'm going to have to store x as 1/2. But I'm going to just do it right now. I'm going to do 0.5 store x, like that. So now x is 1/2. And I'm going to go back up here like this. Now you can hit second enter to pull it up on the older calculators. On the newer calculators, you can just scroll up your screen and hit enter. And now, because I'd already stored x as 1/2, now I can do it again. And you see that I get 0. And that's what we were trying for. This minus this equals 0. I could also graph them, and if I did intersection, they would intersect at 0.5. So what happens, remember, is these are radicals, but is this really like a radical equation? Yes, absolutely it is. I'm going to treat it the same way. This is like a fourth root of x, right? So I'm going to isolate it. I'm going to try and isolate this term right here, plus 7. So now I get 2x to the 3/4 equals 108. Divide by 2 and I get x to the 3/4 equals 54. Now the question is, how do I get rid of a 3/4 power? Well, I know to get rid of a third power, I cube root, and I know to get rid of a fourth root, I raise it to the fourth power. So yes, I literally am going to raise it to its reciprocal. So if I raise it to the reciprocal of that exponent, that should cancel each other out, right? Because I multiply, right? 3 times 4 is 12, and 4 times 3 is 12, so 12 over 12 is 1. So it leaves me with x to the first, or just x, equals. Now here, I have to do 54 to the 4/3 power. I don't know the cube root of 54 off the top of my head, so that doesn't make for a nice, easy problem. So I'm just going to go ahead and do it on here. So 54, and since it's bigger than 1, my answer better be bigger than 54, right? So 54 raised to the, remember old calculators, put it in parentheses, 4 divided by 3 to the 4/3 power. Enter, and I get 204.107, or 204.11. Awesome. Everybody feeling good about that? Okay, so let's try one more right now. So how do I undo this? How do I undo this? Well, this is all by itself. I don't need to move anything left or right. This whole thing is being raised to the 3/3 power. So I'm going to raise that entire side to the 3/2. And if I do it to one side, I have to do it to the other. So that kills that, right? 6 times 6, and 6 divided by 6 is 1. So it gives me 2x plus 4 equals, I can do this in my head, 25. Square root of 25 is 5. 5 cubed is 125. Look at that. Minus 4, minus 4. 2x equals 121. X equals 60.5. And that would be that example. Okay, hopefully that's working out okay for you right now, and that you're doing good with that. I do have a couple problems that go with inequalities in these things too. So just know that if I had something like this, 3x minus 5 raised to the 2/3 is greater than 14. I treat my inequality the same way that I would anything else. Maybe let's put a 2 here. Awesome. So I try and solve this one. Divide by 2 first, and I get 3x minus 5 raised to the 2/3 in parentheses is now greater than 7. I raise both to the 3/2 power, and I get 3x minus 5 is greater than, and now I have 7 to the 3/2 power. I'll do that on my calculator over here. 7 raised to the, I could just make it 1.5 because that's what 3/2 is. And I get 18.52. And I add 5, enter, and then I divide by 3, enter, and I get x is greater than 7.84, which means if I'm looking for values of x, then not only would 7.84, technically it's like here, 0086, so like say 7.85 would work, 8 would work, 9 would work, 15 billion would work to make this true. That's just kind of my boundary. So we're going to kind of cut it off right about there, and we'll call that good enough. Hopefully, this was really beneficial for you. Again, this has been Mr. Bell's solving radical equations. Sorry, my camera's tilting a little bit. For section 5-4, we're skipping 5.3, so don't worry about you thinking maybe you lost a video for 5-4. Solving radical equations. Make sure you do the homework in the Big Ideas Math online section. We'll talk to you guys later.